Yeah, good evening all. Sorry. So before I start, can anyone please confirm whether my voice is clear?
Yes, sir.
Yeah,
It's
clear,
clear.
sir.
Fine, thank you. So before I start, let me just brief you about that content, that what is that course content I'm going to discuss as part of this. So PySpark introduction, what is Apache Spark, why PySpark, need for it, and comparison with Spark, Python, and Scala, real-time use cases, PySpark web application, Spark session, Spark context, PySpark RTD, PySpark parallelize, PySpark repartition, coalesce, broadcast variables, accumulator, PySpark RTD computation, right? How this RTD computations, DAG, direct acyclic graph, various RTD actions and transformations, RTD computations, steps in RTD computations, and RTD persistence, right? Persistence features, persistence options, memory only, memory underscore SCR only, different options for persistence, disk only, disk memory and disk options, PySpark core computations, right? Fault tolerance model in Spark, different ways of creating RTDs, right? Creating Spark objects from increasing the number of partitions. So how we can create Spark objects from Scala, Java, and Python objects, right? Aggregations over structured data and groupings and aggregations. Single grouping, single multi-grouping aggregations, multi-grouping, multiple aggregations, and different versus reduced by key and group by key, process of group by key, reduced by key, reduced functions, various transformations, various actions and transformations like count by key, count by value, sort by key, zip, union, distinct, inner, outer, Cartesian, co-group, other actions and transformations, right? PySpark SQL data frames. PySpark SQL working with data frames, making data structures to create using map and multiple expressions, data frames API, data sets, RTD versus data frames, and PySpark create a data frame, create an empty data frame, convert RTD to data frame, convert data frame to pandas, show struct types, struct field, row class, column class, select, collect, with column renamed, where, filter, drop duplicates, order by, sort, group by, join, right? Union and union, all union by name, UDF, map, flat map for each, sample, fill, null, pivot, partition by, array type, right? Aggregated functions, PySpark SQL functions, right? Aggregate functions, window functions, date and timestamp functions, JSON functions, read and write JSON files, right? PySpark built-in functions. When see built-in, what are the various built-in functions of PySpark, right? When, expression, lit, split, substring, translate, overlay, to date difference, explode, collect list, create map, map keys, map values, count distinct, row number, dense rank, percentage rank, right? And PySpark external sources, working with SQL statements, SQL, Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON files, right? Narrow and wide transformations, addition of new columns, dropping of columns, renaming columns, addition of new rows, dropping rows, handling nulls, joins, window function, writing data back to external sources, right? Deployment modes, local and cluster modes, PySpark stages and tasks, driven executors, building Spark applications, pipelines, deploying in Spark applications to cluster and tuning, performance tuning, PySpark streaming components, integration with Kafka, and PySpark MLlib, right? Yes. This was the course content we are going to discuss, right? Yes. Okay. Apache, it was Spark was developed in the year 2009, and it was donated to software Apache software in the year 2013. It's distributed execution parallel process with in-memory computation, right? Used for large scale data processing. Why PySpark? So yesterday I was just briefing you about these things, right? PySpark used for distributed SQL, data creating data pipelines, ingesting data into databases, ML algorithms, graphs, and data streams. Spark API, Spark plus Python, nothing but PySpark. Spark can be coded with Scala language, Python, Java, and R language. And difference between Python and Scala: Python is dynamic, Scala is static. Python is open source, has large community, it has small community. Powerful libraries for machine learnings and other things, right? That's less compared as Spark with 89,300 inbuilt modules, but here Scala is used only for Spark environment. PySpark features lazy evolution. On demand, we can execute in-memory computation, storage and processing within the memory level, fault tolerant, powerful fault tolerant model, persistence. The already executed transformation, if I want to reuse, can be done, right? Immutability, the original RTD data set is not going to be changed. Real life use cases means in commercial sector, in healthcare, in entertainment, in trade and e-commerce, right? Why Python? Why we choose Python other than Scala and Java means very less coding in Python, simple syntaxes look like normal English statements, hybrid features, multi-programming like procedural oriented, object oriented scripting, and modular, interactive mode, statement by statement we can interact, many built-in libraries, 89,300 modules. Yahoo when first time implemented, Yahoo like it has taken a table of 100 TB consisting of 1024 columns, sorting based on 16 columns. So what is the time taken by the various databases? Oracle has taken 3.5 days, MySQL has taken 6 days, Teradata 4.5 hours, Netija 3 hours, and Hadoop just taken 3.4 minutes. So Spark already Hadoop has got very high speed, but Spark is still 100 times faster than Hadoop. It is 100 times faster than PySpark is mainly designed for batch applications, iterative algorithms, interactive queries, and for streaming, for graph algorithms. Very high speed processing we see in PySpark. In memory, everything happens within the memory level. Storage and processing within the memory level. Distributed execution, multi-language support, supports advanced analytics, parallel processing, persistence, right? Powerful fault tolerant model, right? Yes. RTDs. Yesterday I was discussing about RTDs data sets. Spark data objects are called RTDs. RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slaves. Here the advantage is bigger data sets can be loaded. RTD programming style is data flow. Data flow is a sequence collection of pipes. Spark data objects are called as RTDs. I'm saying RTDs are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple slave nodes, CPUs. And here the advantage is bigger data sets can be loaded. Programming style is data flow asset. Yes. Data flow is sequence collection of pipe. Pipe means any data operation such as loading data, transforming data, filtering data, merging data, right? In Spark, in a, what do you mean by a pipe? Is a data operation. The operation can be loading, transforming data, filtering, sorting data, merging data. In Spark, data flow is executed sequentially, not parallelly, but RTD by RTD.
Here, what is meant by RDD programming style is data flow, sir? Can you please?
Yeah. Yes, I'll give some examples, right? Yes. So data flow. Okay. Yeah, just I'll come back to it. Yes. 1 second. Yesterday I was just 1 second. I was drawing a diagram, right? 1 second. So RTD1 Spark data object is an RTD1, some data set divided into multiple partitions P1, P2, P3, P4, P5 up to P20. This RTD1, RTD2, RTD3 at a time they are not going to be loaded. At a time they are not, for example, there are 10 RTDs. All the 10 RTDs are not going to be accommodated at a time. See, the main advantage of Spark is in-memory computation. Means memory level storage and memory level processing. Means generally, if we see data stores in the disk and gets processed, right? But here data won't be within the disk, it will be within the memory level, within the RAM. Data stores within the RAM and processed within the RAM. That's what we call in-memory computation. So first RTD, if there are 10 RTDs, think that one RTD size is in GBs or in TBs. If 10 RTDs are there, 10 RTDs, each RTD of 1 TB, 10 TBs, that much of RAM is not available to accommodate all the RTDs. Right? If there are 10 RTDs or 20 RTDs, all the 20 RTDs or 10 RTDs cannot be accommodated by the RAM. Only 1 or 2 RTDs you can see within the RAM. So first RTD1 divided into 10 partitions stored across 10 RAMs of 10 slaves, right? Stored in distributed across 10 RAMs of 10 slaves. These slaves, 10 slaves, 10 worker nodes, they are going to execute parallelly. They use the result, the output.
This all becomes a part of RTD1 only, right, sir?
So RTD1 thinks that a big data file, data object, it is divided into multiple partitions, into 20 partitions. 20 partitions. 20 partitions are stored across 20 systems within the 20 RAMs of 20 slaves and are processed parallelly. Two things: distributed storage, parallel processing. You can see, right?
Yes, sir.
They are distributed across multiple systems and are processed parallelly by 20 systems. Okay, once you got the output, the output is taken as input by the next RTD, RTD2. Until that, RTD2 cannot be loaded. Until RTD1 gets computed and gets the result, RTD2 cannot be loaded into RAM. Now RTD2 gets loaded into RAM. Once RTD2 is ready, RTD1 will be removed from the RAM. Once you got the output, when RTD2 is ready, RTD1 will be removed from the RAM. It cannot accommodate multiple RTDs. That's why whenever RTD2 ready, RTD1 gets removed. Okay, RTD2 output as taken as the input, is given as the input to the next one. Okay, RTD2 gives the output to RTD3. This RTD1, RTD2, RT3 means RTDs are executed one after the other sequentially, but the RTD partitions are executed parallelly.
Okay.
So it's a data flow. One output is input to the next one, just like a pipe. One output is input to the next one, that output is input to the next one. This entire flow won't execute automatically until you perform any kind of action. You see, I've written, if you perform action, then only the entire flow executes.
Yeah, got it.
That's what we call it as lazy evolution. On demand, we can execute them. On demand, we can execute them by performing an action. So RTD3 dot action, if you say, then the flow executes from RTD1 to RTD3 and RTD3 output is collected. Fine. So this is what data flow. So you need to understand about this RTD computations, and there are some few things that you're supposed to understand, like persistence, fault tolerance. Okay, coming back. In Spark, data flow is executed sequentially, RTD by RTD, one after the another, with in-memory computation feature and persistence feature. Persistence, okay, I'll come back to this persistence. Lot of discussion on this persistence. RTD1 is there, RTD, these two RTDs cannot execute in parallel. If RTDs has 20 partitions, then these 20 partitions can execute in parallel. The output of RTD1 is the input of the RTD2. On a RTD, two types of operations we can perform. On any RTD data object, two things, transformations and actions. Transformations, again, three types. Each element transformation, like using map and flat map. Each element transformation means whatever transformation you are applying, business logic you are applying, will be applied in each and every element. If there are 1 lakh, all the 1 lakh records, the transformation applies. That is each element we say. Next is like filter transformation. Filter and filter by range. Aggregated transformation. Filter means like based on some product wise, department wise, city wise, some condition we provide, that aggregated transformations, groupings, actions. Next is one more thing is actions. Action means whenever an action is performed, whenever any action is performed on a RTD, then only the entire data flow will be executed from the root. Until then, the flow won't be executed. Anytime, if you want to execute the flow, if you perform action only, then the entire flow will be executed. Otherwise, it's not. The following are some actions, like collect. Will collect the partitions data. Count. Counts the number of elements of an RTD. Takes the first 10 elements of an RTD. Similar to limit in SQL. RTD dot take of 10 means takes the first 10 records. If the partition has only 5, remaining 5 will be taken from partition 2. Save as text file is also one action for storing the results into file like HDFS or Linux file. So here RTD1, RTD2, 3, 4, 5. First, using Spark context, if you are loading any text file, RTD1 gets created. How RTD1 creates? If you are loading any file using Spark context, the result is an RTD. On the RTD1 available, right? On that, if I perform any map transformation, mapping, RTD2 is created. Map means, for example, adding 5,000 to the salaries of each employee as bonus. That same thing is going to be mapped for each and every employee. The result what we get is RTD2. RTD2 dot filter, if you perform any filtering operations or transformations, right, the resultant also in RTD. Groupings or filtering or mapping, agree. So all this, the resultant is in RTD. Finally, say RTD5 dot collect. Where these 5 RTDs are stored means they are not, they are stored or loaded one after the other into RAM only when action is performed. After the execution is completed, how many RTDs within the RAM is 0. Everything gets removed. RTD1 output is input to the RTD2. RTD2 output is input to RTD3. Once the total execution finished, it collects the output and RTD4 also gets removed.
Sir, here after execution, one RDD will be there, right? For example, RDD1 is executed, that will remove from the memory and it moved to RDD1 as output, right, sir? At the time, it should be one, right, in the maybe a RAM.
RTD2, 3, 4. When RTD4 is ready, RTD3 gets removed.
Yes, sir.
Then RTD4 should be available, right?
Yes, sir. In the sense, one it's there in the RAM, right?
Once the total execution is completed, right? Once the output is collected, the final RTD also gets removed from the RAM.
Okay.
Once the total execution completed, once the output is collected, the final RTD also gets removed. Now that RAM is empty, next you can trigger the next flow. Again, that also one by one, they are going to get loaded, executed, and final RTD output will be collected. Again, they get removed. Now nothing is done.
Okay.
So if you see this, if any RTD's output is commonly used by many flows, so make persistent RTD whose output is commonly used by many flows. R1, R2, R3, R4, R5, R6, R7, R8, R9. So this is flow 1. This is flow 1. This is flow 2 down. Flow 2. This is flow 3. In all the 3 flows, first 3 steps are common. First 3 steps are common. So persist this R3. Why I need to persist R3? Because its output is used by all the 3 flows. If I persist it, so that directly I can start the flow from R3. See this R3, R5, R8. R3, R5, R8. No need to start from the beginning, right? R3 is available in the RAM if I persist it. Persisting means making the RTD available in the RAM even though the next one is ready. When R5 ready, R3 won't be removed. When R8 ready, it will be removed. This also gets removed. Flow 2. In flow 3 also, right? From R3 to R6 to R9. This and this gets removed, but still this will be available, right? Means, I mean, no need to execute from the starting. Directly, if you persist any RTD, it will be available in the RAM, gives output to the other RTDs, other flows. Yes. Once your total execution finished, we can unpersist that RTD. If persisted R3 is not required, then forcefully we can unpersist it. 3 ways to unpersist. RTD.unpersist when session is closed, when server shutdowns. 2 situations where RTD will be removed from the RAM. Whenever the next RTD is ready, the previous RTD will be removed from the RAM. When the execution is completed, the last RTD also will be removed from the RAM.
Hello.
Yes.
Uh, Sir, here RDD2, uh, RDD1 will be removed only when RDD2 is created, right? So if I use just union or join operation, so there is a small period of time. We have 2 to 3 RDDs in the RAM, right?
Mhm. So based upon your task, right?
Is my understanding correct?
So you want to perform any
Yeah.
kind of merging operations, vertical or horizontal merging. Vertical means union, horizontal means join. If you are performing any kind of merging operations. Hmm. Two RTDs outputs you are going to collect and RTD3 is going to get created.
Okay, so that is a small period of the time. So at least with respect to memory, so maximum resources are used, right? So that should be the threshold while configuring the job.
No, no, no. Actually, we will be giving options, right? If unable to fit into memory, we will be giving memory and disk option. If you feel that if you're shortage of memory, right, instead of
Yeah,
if the job failure, we can also persist or we can just store it in the disk, memory and disk options. So here, when I was showing you, right, various options in your this course content, I was just showing you various persistence options. Only memory you want. In such case, if you see that if a bigger RTD, if unable to fit into memory, then the job fails, right?
okay.
So in that case, you can go for memory and disk option. If unable to fit into memory, then it can. Otherwise, already the RAM is busy with other RTDs. Already it can fit, but the memory is totally filled with other RTDs and working with other RTDs. Currently,
Yeah,
RAM busy with other RTDs. Now it cannot fit, but later if it becomes fit, it can fit. In such case, I want to, instead of job gets failing, I can just persist in disk, right?
okay,
So in the
okay.
such way, whenever available, then in RAM, otherwise in disk. In this way, you can do that. There are many options: persistence, memory, and in serialized format, it will occupy very less space in serialized format. And disk only. If you want only in disk or in disk underscore serialized memory and disk, right? So if I see the complete process step by step, right? 1 second. What do you mean by lazy evolution, right? On demand, we execute. Steps in RTD computation. So from the understanding, from what you have understood, right? From the discussion of this RTDs, we'll just summarize, right? Steps in RTD computation first. Step one. Step one. Initially, all the RTDs. Initially, all the RTDs are just declared. We execute them on demand. We execute them on demand by performing an action. Initially, all the RTDs are declared. We execute them on demand by performing an action. this type of evolution. Lazy evolution, right? Yes. This type of evolution is called as lazy evolution. Active evolution means when loaded, should be whenever loaded, immediately executing. Executing when declared, that's it. But here it won't until you perform an action, right? Spark supports only lazy evolution only. Whenever required, executing, right? Yes. Step 2. When action is performed, See, just like if you got knowledge on Apache Pig in Hadoop, right? Lazy evolution, not evaluation. When action is performed, if you have got knowledge on Apache Pig, if anybody has got knowledge on Hadoop, right? Pig also. It's a data flow language, Apache Pig. Until you say dump, it won't execute. When action is performed, what happens? Flow execution. When action is performed, flow execution starts from its root RTD. Sorry, it's root. Or available RTD if anyone is persisted. Step 3. During flow execution, each RTD partitions during flow execution, each RTD partitions data will be loaded into RAM and computed. Each RTD partitions will be loaded into RAM and computed at RAM. Step 4. Once RTD computation is over, if next RTD is ready, once RTD computation is over, if next RTD is ready, previous RTD will be removed from the RAM. This process continues till the action is completed. Once RTD computation is over, the next RTD is ready. Previous RTD will be removed from the RAM. This process continues till the action is completed. When action is performed, all RTDs are stored in completed Spark side. But the final result
Sir, this the number of, for example, you given one example, say it's a 1 TB file got loaded into using a Spark context. This the number of splitting everything we are going to configure, our system will automatically it will take care, sir.
So by default it takes, but even we can control right into how many you want. While loading it, we can give comma and specify that how many you want.
Okay.
So that is what in Spark that advantage is. We can control the parallel process, but in Hadoop it cannot be, right? It depends upon the blocks, how many blocks the data is divided in those many, right? But here
Yes.
we can control the parallel processing.
Yes. Sir, in generally, I have one doubt here. For example, Spark, it's say so cluster is one different RAM systems, right? In order to work in local system, will that allow to get all this kind of performance, or how it will be, sir? In local individual laptops or desktops, we
Yes,
wanted
yes.
to perform this.
So all those partitions will be stored in a single, right? Yes, you can load it and you can work with it, but you won't see the parallel processing.
Okay, okay. Here, for example, maybe it's depending upon the laptop configuration, multi-threads will be there, right, sir? It's based on the this one processor i5 or i7. There's a multi-thread model. Will that allow to do?
Okay, generally, whenever we are this cluster, right? Yes.
Mm,
So multiple RAMs, we have got multiple RAMs, right? So means I got 10 slaves, 10 systems, 10 CPUs, right? Connected in a network.
okay.
So here we follow master slave architecture, not server, single
Okay.
master, multiple slave. We'll
Mm,
follow single node cluster, we say, multi-node cluster, we say. Single node cluster, we will see that master and slave there itself, but multi-node cluster, single master, multiple slaves. So your got multiple slaves will have multiple RAMs, right? So your
yes.
data also is going to get distributed across multiple RAMs of multiple slaves
Okay.
and are processed parallelly. So they can be processed parallelly, right?
Yes. Then our laptop or desktop, it's a single. It's a master slave will be there in the same.
So yeah, in such case, you won't see parallel processing. Everything will be loaded in that. That only need to process everything.
Okay, sir. Yes, sir. Got it.
So here the final result is collected and stored in client machine. What do you mean by client machine? The machine from where you are submitting the job.
So it's a driver.
Pardon?
So like when we submit in masters, any job we submit in masters, that is the client.
Yeah, we have got drivers and executors. No. The machine from where you are submitting the job. Generally, what do you mean by client machine? Means the machine from where you are submitting the job. It can be anything, right? Within the cluster also.
Okay.
Step 6. During the flow execution, right? During the flow execution, the RTD which is commonly used, the RTD whose output is commonly used by many flows. Will be persisted. During the flow execution, the RTD whose output is commonly used by many flows will be persisted. Persistence means making a RTD available in RAM. Step 7. Finally, the RTD stored in RAM will be unpersisted Okay. So here these are the steps, right? The RTDs will be loaded one by one into the RAMs. And whenever the next one is ready, the previous one gets removed. So here, the RTD, this R1 is the first RTD, R2, R3, R4, R5. R6, R7, R8, R9. This is just defined if you're just performing any action. R5 dot collect, if I say R5 dot collect, if I say, then the execution starts first. When R2 is ready, R1 gets removed. When R3 is ready, R2 gets removed. But if I persist, this R3 output is used by 3 flows, right? So I'll persist it. Persist means making it available in the RAM even though the next one is ready. When R4 is ready, still it will be available. When R5 ready, this gets removed. When the total execution finished, this also got. Now what is present within the RAM? When the flow one executed, this one, which is available?
R3.
R3 is available, right? R3 is available means whenever I want to execute this flow, this one, flow 2. So R7 dot collect, if I say R7 dot collect, action, collect or count or anything, right? First it will check R7 input is what?
R6.
R6, right? This is R6, right? R7 output is R6. R6 input is R3. R3 available RAM, right? So no need to execute from the starting. So the flow will be from R3, R6, R7. R3, R6, R7. When R6 ready, still R3 also available. When R7 ready, this will be removed. This will be removed, right? Only R3 is available in the, within the RAM. Now also means here we are not re-executing from the starting. If any common steps, first 3 steps are common for all the flows. Again, no need to re-execute from the starting. R3 is available in the RAM to give its output. So R3, R6, R7. Similarly, flow 3, R9 dot collect, if we say. First we'll check R9 input is what? R8. R8 input is what? R3. R3 available. So the flow is R3, R8 and R9. When R9 ready, R8 removed. When total execution finished, R9 also removed. R3 available in the RAM, right? In all the flows, R3 will be available. The flow, that means the RTD whose output is commonly used by many flows, we persist it. More discussion on this. Discussing more on this persistence, right? Yes. Persisting in RTD means making the RTD available in RAM. Persisting in RTD means making the RTD available in RAM. Even though the next RTD is ready, the persistent RTD won't be removed from the RAM. Advantage, what advantage we see? Advantage of persisting in RTD, right? What is that advantage?
we can avoid multiple similar executions.
Advantage of ICS. If a RTD is persisted, the other data flows can reuse the executed transformations. Transformations can be reused. Example, transformations can be reused. So we need to follow some rules here also for persistence. Rules in persisting in OTD. The RTD whose output is commonly used by many flows, that RTD need to be persisted. Second one is we need to persist the RTD before action is performed. We need to persist the RTD before action is performed. Before the action only we need to persist it. After action we cannot persist it. And one more important, right? For persisting an OTD, right? For persisting an OTD, at least one flow should be executed. One flow should be executed. Next one. RTDs will be persisted when first time they are loaded, right? The RTDs will be persisted when first time they are loaded. RTDs will be persisted when first time they are loaded and computed. even though the persist option is specified in the later steps, even though the persist option, right? Two ways to persist in OTD. First one, right? RTD dot persist. Second is RTD dot cache. Okay, the difference between these two is RTD dot persist make use of all the options, disk, memory, and disk, all that options. But RTD dot cache only one option, that is memory only. Just I'll provide some examples. You try to say whether which are valid and which are not valid flows.
Sir, the fourth number, RDDs will be persisted when first time they are loaded and computed. Even though the persist option is specified in the later steps. What does it mean? We do persist after computation, right? After first computation.
One second. To understand the 4 steps, to understand all these four, right? Just
Yeah.
observe these examples, right? Yes. So first, okay, before okay, just observe. Already one created from sc.text file path. How RTD2 is created? RTD2 is created from RTD1. On RTD1, if you perform any transformations, right? Mapping something, right? Yes. RTD2. How RTD3 is created? From RTD2, if you perform any filter operation, right? Now observe here, you are asked a query, right? The fourth one, RTD will be first when first time they're loaded. Even the persist options is, see here, instead of saying RTD here, after saying RTD3 dot persist here, I need to say RTD dot persist here, right? But what I do, I won't give that RTD that persist option here. After RTD3, after RTD4, after RTD5, if I give this option RTD dot persist, RTD3 dot persist, RTD5 dot collect action. Do you think RTD3 gets persisted here?
No.
When RTD2 is ready, RTD1 removed. When RTD5 ready, RTD4 removed. Finally, whenever you come to RTD3 dot persist, will it be persisted? Try to answer everyone.
No.
No, sir. No.
Okay.
Whether RTD3 available in the RAM?
No, it won't
No,
be.
sir. No, sir.
Now clearly observe the steps, right? What is happening in the RAM for this flow? RTD1, first what happens? It loaded. Here the answer is, for this flow, RTD3 is persisted and RTD3 is available in the RAM. Once the execution finished, RTD3 is persisted and RTD3 is available in the RAM. That's what the fourth one. Even though the RTDs will be persisted when first time they are loaded. When first time is when RTD3 is loading into the RAM, then only it will be persisted. Even though you give the persist option in the later steps. Even though you give the persist option in the later steps.
It means that when we will declare RDD3 persist after RDD3, then only it will remain. But before, after RDD3 execution, if we will give, then it won't.
So in a simple way, I explain, right? Just observe this. What is the R1 is there? RTD1, R2, R3, R4, R5. R3, okay. R2 equal to R1 dot R3 dot persist. R5 dot collect. Whenever you say R5 dot collect, right? Whenever R5 dot collect, right? You are performing action on R5, then it will start. R5 input is what?
R4.
R4.
R4 available in the RAM? No, right? R4 input is
R3.
R3 is it available in the RAM?
No.
No. R3 input is R2. R2 input is R1. R1 input is 5. So it will first check from where can I get the input for R5. So it should get R5 from R4, R4, R3, R3, R2, R2, R1, R1 to. So during this process, it will come back. See, it will just check from the bottom. From where can I get? During this process, it will come to know which RTD I need to persist during the flow. Which RTDs I need to persist during the flow. So when first time R1 gets loaded into the RAM, next R2 gets loaded. When R2 is ready, R1 gets removed. Next, when R3 gets loaded into the RAM, immediately it will persist it. Even though you are given persist option after R5. So whenever it already came across all this, right? Which RTDs I need to persist means whenever R3 first time loading into the RAM, then only persist it. R2 gets removed. When R4 ready, do you think R3 gets removed? No, right? When R5 ready, R4 gets removed. When total execution finished, R5 also removed. What is there in the RAM now?
Okay.
Not 3, right? Now have you understood?
Yes.
Wherever you give that persist option, after R5 you give or after R10 you give. Whenever the flow is executing one by one from the first RTD by RTD, when the RTD 3 first time it is getting loaded into RAM, then only it will be persisted. Wherever you give the persist option after R10 or R20.
Okay.
Everyone understood, right? Any query in this?
No, sir.
Sir, if we give that after the action, so in that case, it should not work, right?
Whenever you give after the action, right? First this action, this execution totally completes. What is present in the RAM? No RTD, right? Once your total action completed, no RTD will be in the RAM, right?
Yeah, yeah.
Then the next step, R3 dot persist. R3 is not available to persist, right? R3 won't be available to persist. Once your action completed, total execution finished, no RTD remains in the RAM, but your next line you are trying to provide R3 dot persist. You are trying to persist an RTD which is not available. After action, no RTD will be available, right?
Okay, sir.
So in this, any other query, right? So that's
Sir,
why
the output from all this
the
sir,
output, yes,
collected in collected by client mission, as you said, but how it will be collected? There will be no RDT present in RAM after
so when the total output is completed, R5 output will be collected
execution
after here.
action got completed. Then driver that client mission, how in which form the output will be, sir?
So 1 second.
Yes. After the in a RAM, no will be present, but will collecting, right? So that mission, as you said in the
Finally, R5 dot collect means the R5 dot collect means what is the output you get? A Python object, a Python list, a Python collection, right? Transformation on RTD results as Spark object only RTD. Here in these examples, if you observe, on RTD2, if you are performing some filtered transformation, the output RTD3 is an RTD, right? The output is also an RTD. RTD5 dot collect, if we say the res is a Python object. It's not a res. The final result is a Python variable, Python object. If you perform action, finally the output you are going to get is Python object only. On an
okay.
RTD, any transformation you apply, filter, map, group by, transformations always returns an RTD as output. But action, if you perform finally, it results a Python object.
Okay, sir. Thank you.
So here in the previous example, RTD1 first time loaded plus computed. RTD2 loaded, computed, and ready. Now R1 will be removed. When RTD3 loaded, computed, and plus persisted immediately whenever it is loaded. Whenever an RTD getting loaded into RAM only, the persisting will happen.
Sir, for example, if the RDD3 gets reassigned multiple times before the collect operation, so which will be available? Whatever
The-
it is loaded first time or the recently computed RDD?
Recently computed.
Okay.
Always the latest value. X is 10, X is 20. Always X takes latest 20, right?
Okay.
Here also same.
So if there are no computed operation, RAM will contain whatever it loaded first initially, right? I mean the first transformation.
So you are saying that RTD is persisted?
Yeah.
If RTD, okay, RTD3 equal to RTD3 equal to. So what happens is the second one only available or writes.
Okay. Okay, got it.
Loaded, computed, persisted immediately and ready, right? RTD4 loaded, computed, and ready. R3 won't be removed. R4 will be removed. When execution is complete. When execution is complete, RTD5 also gets removed. Now observe this flow, right? 1 second. 1 second. Observe this flow one, right? Examples. R1, R2, R3, R3, R4, R5, R5 dot collect. Here after R3 I've given persisted. Here after, okay, here after R3, here after R4, here after R5 I've given. Do you think R3 get persisted here? After R5 I've given the persist option.
Yes.
Yes,
Yes, sir.
after R4 I've given the persist option.
Yes, it will persist.
Yes, sir.
After R3 I'm given. So understood, right? Understood that fourth point, whatever I discussed here.
Yes, sir.
That was RTDs will be persisted when first time they're loaded, even though the persist option is specified in the later steps. For persisting an RTD, at least one flow should be executed. We need to persist the RTD before action is performed. See this in all the above three flows. In all the above three flows, wherever you specify the persist option, the RTD will be persisted only when it is first time loaded and computed. Whenever we say RFID, it checks. During the checking process, it will come to know which RTDs need to be persisted. While loading, now the flow starts and loads one by one and persists the required RTDs when loading only. Can we persist two RTDs in a flow? Can we persist two RTDs in a flow?
I think yes, sir.
Yes, we can persist two RTDs. Observe here. R1 to R5. I want to persist R2 and R3. Both on R2, R3 will be persisted. Even though I given the persist option after R5, when R2 getting loaded, it will be persisted immediately. When R3 getting loaded, it will be persisted. Both will be available in the RAM, right? Even though the action is completed. Yes.
Yes.
Yes, sir.
Yes.
Persist option. See the other flows. Flow 5. R2 dot persist I have given, R3 dot persist here. Here also both R2 and R3 will be persist. After R2 immediately I persist, after R3 immediately I persist. Wherever you give the persist option, it should be given before the action only. In the above flows, flow 4 and flow 5, the execution. R5 input is R4, R4 input is R3, R3 input is R2, R2 input is R1. R1 input is file. Now during this checking process, it comes to know that R2 and R3 need to be persisted during loading. During this, which input is what, right? During this checking process, it will come to know. The flow is R1 loaded, R2 loaded. When R2 loaded only persisted. When R3 loaded only persisted. When R4, this way. Observe this flow 6. After collect, I said persisted. Do you think it will be persisted? After collect, after action. After action means this entire flow executes. Now no RTD in the RAM. Now he's saying R3 dot persist. Will it be persisted? It won't be persisted, right?
No, sir.
Here R3 won't be persisted because when action execution complete, we are trying to persist, but by that time no RTDs in the RAM, right?
Sir,
See,
how many are there?
R1 loaded, R2 loaded, R3 loaded, R4 loaded. Whenever R4 loaded, R3 will be removed. When execution is completed, R4 also removed from the RAM. Now no RTD in the RAM. Now you are trying to persist on 3. Some query was asked.
So how many RDDs are persisted in at the time?
See, generally, if you have got huge RAMs, you can persist multiple RTDs, many RTDs or multiple RTDs. Otherwise, we'll persist only.
That means n number of.
See, for example, if you have got 70 RTDs flow, while I'm executing R60, some failure happens. So if I persisted R50 means again you will start the flow from R50, not from the starting. While computing R60, suddenly some execution failed. In such case, no RTD available in the RAM. Up to R60, R59, one by one they got removed. Now R60 is loaded into the RAM. But previously I didn't persist any RTD. In such case, again you need to start the flow from R1, R2 to R69 again, R60 again. But if I persisted R50 in the middle, then I no need to execute from the starting. Directly from R50 I can continue my execution, right? But if you have got good RAMs, I persisted R25 and R50 while executing R48, some error happened. R25 you can come on, no need to come from the starting. But whenever you said you will be persisting R25, but up to R25 you are still at R23 only, at R23 only. At that time some error, now again you need to come from the starting. In such case, for every 10 RTDs you can persist if you have got good RAM. Understand?
Okay.
Observe this flow 6. Here R3 dot collect I said. R3 dot collect I said means R1 to R3 only it will execute. But after R3 dot collect I said R3 dot persist. And again R4 is there, R5 is there, R5 dot collect is there. Here R3, is it persisted or not persisted?
Not persisted.
R3 not persisted because after action you have given it. Here R3 is not. The flow starts from R1 to R3.
Sir, in the flow 6, for example, I wanted to make use of R3 in the next maybe processing further. So again, I wanted to create a Spark object and I wanted to make use, right, sir?
If you want to use,
So for example, R3, we are creating the action here. Now this will return the Python object.
yes.
So in order to use next computation, maybe R4, 4, 5, 6, 7 something. So again, I wanted to create RDD using this one.
R3 not persist, again R4 some operation, right? Yes, you need to.
Yes.
But here not like that. R4 equal to R3 dot map means R3 output, R3, okay, here you said collect. Okay, R3 dot persist, if I say it won't be persisted. But whenever R4 taking input from R3, think that this collect is not available. If this collect and this not available, if these two are not available, right? In such case, R3 output will be taken as R4 as input. Some operation you are doing on R3, the result whatever you get is nothing but R4. If these two are not present, R3 output it takes R4. Observe this flow 7. R3 dot collect I said, R5 dot collect I said. Here flow executes from R1 to R3. Here if I say R5 dot collect, flow executes from R1 to R5 because R5 input is R4 not available. R4 input is R3 not available. R3 input is R2, R2 input is R1. So from R1 to R5 it executes and finally R1 output is collected. Can I persist to RTDs means yes. R3 dot persist, R2 dot persist. Anywhere I can.
Sir, I am not clear. Like first we have before this one like R3 dot collect. So when we do R3 dot collect, then Python object will be created, and at that time R3 won't be there. So how R3 will come in R4?
RES equal to R3 dot collect. So here RES equal to RES equal to R3 dot collect. So here whenever I am showing this R4 equal to R3 dot map, R5 equal to R4, R5 dot collector. So if I'm saying in this flow, if I say here itself, I doesn't want this R4 and R4. In such case, you will be keeping this in comment. You won't execute that. It means I've defined this 5, but I doesn't want that 5. I want this the first 3 results only. Then here you can say RES equal to R3 dot collect.
No. So here doubt is even my doubt. For example, here with the same flow without any comment, I think sc dot text file of R3. So again, maybe RES or something we can make use of same thing, right, sir? Here.
In this case, if you want this flow to execute the second of, right? So here you need to say persist. R3 dot persist. Now the flow executes. R3 is available in the RAM, right? So now your total execution completed. Your total execution completed. R3 dot persist. So this output is collected up to first 3 only. Next, R3 is available in the RAM. R3 is available in the RAM, right? You can get the output and R4 gets computed. Here if you say R5 dot persist, it's not will persist.
So sorry to extend this. Just can you R3 dot persist? Can you please enter something? So just I have one doubt here. In R3 dot persist, can you please just enter command? Enter just comment R3 dot persist and enter. So yeah, now what? Anyway, till this R3, maybe everything will be vanish in the RAM. Now what I'm planning is just make use of this one RES, right? Just what I'm planning is sc variable R3 equals to sc dot text file of I'm passing RES as an input.
No,
Now in my memory R3 will get created. So for the transactions I can able to make use of this one, right?
1 second. R4 to execute, right? R4 to execute compulsory R3 output required. R4 if you want to execute compulsory R3.
Yes.
See here compulsory R3 output. See here, observe this. R3.
No, that's the reason I'm making this one creating as a one new RDD here. Right?
No, here R3 RTD3 output on that I'm performing map. Whatever result you get from this, whatever result you are getting.
Okay, sir.
I'm saying it as RES2. I'm saying RES2 is what? An RTD. It's not doesn't mean that I need to give the name R4 only.
Okay.
I'll give RES2.
Yeah.
Next RES2, I'll perform some operation on RES2. I'll get RES3. Observe here.
Got it.
Understood,
No,
right? Understood, right?
Yeah.
So
Thank
here compulsory RTD3 output, I am performing some filtering operations. On RTD3, I'm performing some filter operation or map operation or group operation. The result, whatever you get, that is nothing but any name you can give, that is giving R4 answer. The result is an RTD only. But R3 should be available, right? R3 should be available to perform something, right?
Yes, sir.
So
Yes.
that's why if it wants to be there, then if we say res.collect, so everything will be vanished. So in such case, persist it if I want to perform. Otherwise, if you are giving this collect at the last, then everything. Understood now?
Yeah. Yes. Thanks, sir. Thanks for this.
Sir, is there any possible to RDD R3 are deleted to process the data?
Or RTD?
RTD, is there any possible to delete or collapse or something else to do?
RTD, no need to do all those. Anyhow, it will be removed from the RAM automatically. Automatically, the RTDs gets removed whenever the next one is ready. Whenever the total execution finished, it will be automatically removed, so that the next job to execute, right, it makes space for it. The next job to execute again, one by one RTDs will be loaded.
Okay, sir. Okay.
So here, if we start another job, then R3 is persisted. So that time also we can use that R3, right,
Yes.
sir?
Yes, R3. If you want to use another, you can trigger anything where R3 output is required, means compulsory.
So it means like forcefully we need to unpersist if we don't want.
If you don't want, you can forcefully unpersist, saying R3.unpersist.
So automatically it will never unpersist, right?
Unpersisting happens immediately. So about those things I'll be discussing, but unpersisting happens immediately. Persisting won't happen immediately. For example, there is up to R1 to R90, there is a flow. I want to persist R80. Immediately R80 won't be persisted, right? Before R80, 79 RTDs need to be loaded into RAM. When R80 is loaded, then it will be persisted, right? Until then R80 is not persisted. Means if you want to persist R80 before R79 RTDs need to be loaded into the RAM. Next, when R80 is loading into the RAM, then only it will be persisted. Until then, it won't be persisted. Whenever you say R80.persist, immediately it won't be persisted when it gets loaded. But second time, any other flows make use of R80 output. Second flow, third flow, fourth flow, when R80 is available in the RAM. Second time, third time onwards, directly R80's output can be used. But first time, when RTD is loaded, R80 is loaded, then only it will be persisted. But unpersistence, already you got some 4 RTDs in the RAM. You have persisted 4 RTDs in the RAM. Whenever you say R5.unpersist, immediately it will be unpersisted. Understanding?
Yes, sir.
Unpersisting happens immediately, but persisting won't happen immediately. When it gets loaded, only it happens. But whenever you say R5.unpersist, immediately it will be removed from the RAM, so that that output can't be used by other flows. Okay, fine. So this was regarding this RTD, right? So we have got more discussion on this fault tolerance model. Suddenly, if any system goes down, if a system, see that, for example, if any system goes down, then how? If a persisted RTD machine is down, then how? If a normal machine is down, how? Then if a persisted RTD machine is down, then how it is going to get, right? It has got powerful fault tolerant model. So some more discussion before we go with the practical part, right? Fine. Yeah, yes, this notes, everything you'll be getting, right? Everyone, you'll be getting these notes in the step by step, everything. I just, not only this, whatever our notes, whatever I type, RTDs computation, step 1, step 2, how the RTDs are computed, right? What are the various actions, transformations? What is resilient distributed data sets, Spark data objects, features of Spark, PySpark, mainly designed for why Python. Okay, this everything I'll be forwarding you, right? Fine, you'll be getting the video also, right? Video sessions of this. And if you can see the chart panel now, the online team has posted that the payment details, other things, right? So the next Saturday, the link will be changing, right? Only those persons who have enrolled. See, the notes who got enrolled will be getting a Google Drive link, right? Google Drive, in that you will be getting the videos up to now, how many sessions happened, that videos you can check in this Google Drive. Shared with me option will be there, right? It's in that, you can check. And a WhatsApp group is going to be created next Saturday. And notes you will be getting, right? Within 1 or 2 days, you'll be getting the, within by tomorrow, you'll be getting the notes who got enrolled, right? You'll be getting the notes and the WhatsApp, Google Drive videos link you'll be getting. And also like software you'll be getting. I'll be demonstrating about the software next Saturday, right? So the things who, so get enrolled for getting these notes, videos, software, right? And adding into that WhatsApp group, right? You can check it in this chart panel, right? The details, everything posted. And also the course content, you can see that they have posted class notes, videos, and soft copy of the materials. And also you can make a note of the contact details of the online team for any further references. And also you are supposed to send the screenshot of that payment to them, to that specified mail ID provided by them, right? Sign. Fine. Okay.
So probably from next week, regular sessions will start, right, sir?
Yes, we'll be continuing from here onwards, right?
Yeah.
From the where we have stopped, right? From there itself we'll be starting.
Thanks.
Yes. Vidya,
Yes.
yes. I'll be just, before I go with, I'll be giving some syntaxes. I'll be discussing about some Python syntaxes one day, right? Before I start with the actual practical part. So the Python syntaxes, it's not like as complex. You can just, you can also learn by yourself, right? Yes.
Okay, sir. Thank you.
They look like normal English statements.
Sir, is there any project regarding this PySpark?
So at the last, I'll be showing you the flow, right? Flat flow.
Okay.
So what are the scenarios we should choose for the persist? So persist and cache difference is persist make use of all that options within the disk, within the memory and disk, but cache, it has got only one option, memory only. It cannot make use of disk option. Whenever you are persisting, right? Persist.cache, if you are saying, it can make use of only memory option only. No, there won't be any disk option for the cache. Persist means it takes all memory, disk, and disk, right? Yes. Fine. So I'm stopping here. So if I'm done with the queries, if there are no other queries, then I will sign off for now. Meet you in the next Saturday at 3 p.m. right? The link, you'll be getting a new link to your mail IDs, right? Yes. Fine. So okay, I'm stopping here. We'll continue.
Sir.
Yes.
Sir, sorry to interrupt, sir. So I have one question, sir.
Yes.
Like at the end of the course, what are the projects we are going to do, sir? Based on,
I'll be showing you one flow, project to flow, right?
Okay.
How this flow goes in the project, that I will be showing you.
Okay, sure, sir. Okay, thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.